All right, units. This is what gets everybody. So meters per second. That's a distance over a time. Distance divided by time is speed. Day. It was 1 day. It was 2 days. It was 3 days. That's a time. Kilometers per hour. Distance over time with the big letter at the end, which probably is going to represent north, south, east, west, up, or down. That's going to be a velocity. If you see something at the end, it's probably giving you a direction, which tells you it's going to be velocity. S is seconds. Seconds is time. M is meters. That's a distance. Kilometers per hour. That's a distance divided by a time. Distance divided by time is speed. Miles per hour. This is a weird one. Instead of doing a slash, there's a P. That's just an American thing. So miles per hour, that's speed. Kilometers. Kilometers. Kilometers and kilometers, that's distance. Miles. If you go run a mile, you ran a distance. That's distance. Hour. That's a time. Miles per hour downhill. That's a direction. So velocity. That's a speed with a direction. Meters per second in. Meters per second. That's a distance divided by a time with a direction. That's velocity. Next section. What's the standard SI unit, or what's the unit for measuring distance? That's going to be the meter. Okay. That's a time. That's a mass. That's a volume. This is the only distance in this whole entire set of questions. Which of the following best defines speed? It's time divided by, or distance divided by time. So distance per unit time. Distance per time. Miles per hour. Per is like to divide by. What is the formula for calculating speed? Speed equals distance divided by time. Distance per time. Distance divided by time. Which of the following units is used to measure time? Not meters, that's a distance. Seconds is definitely a time, but let's check the rest. Newtons, no, that's force. Joules, that's also force. So moving on. What's the key difference between speed and velocity? Velocity has a direction, so is there anything that says anything about direction? Speed includes direction, but that's wrong. Speed is a scalar quantity, while velocity is a vector quantity. This is the best answer. This was actually a bonus question from the reading, so if you get this, is the bonus point. Scalar means no direction, vector means there's a direction. If an object is moving in a straight line for 30 meters per second, what is this measuring? 30 meters per second. Meters per second. Meters per second, that is a speed. What is the SI unit for speed? Speed should be a distance divided by time, so meters divided by seconds. There it is. None of the rest of these are that. In fact, this one's just backwards. So that's the best answer, meters per second. If an object just travels more or 100 meters in 50 seconds, what's its average speed? Distance divided by time. 100 divided by 50. 50 can go into 100 two times, so 2 meters per second. Which of the following is not a valid unit for speed? Not a valid unit for speed. We need a distance divided by a time. That is a distance divided by a time. Yes, a distance divided by time. Yes, that's in. We haven't even talked about in yet. Divided by time. That's the answer because it says not. An object's velocity includes which of the following components? It includes distance. Nope. Speed and direction. Yeah. Speed and direction gives us velocity. All right. Which of the following best describes the motion represented in the time graph? So we've got some speed here, constant speed, and then we stop, and then we start moving again, a little faster now. So the object is moving at constant speed the entire time. No, it stopped right here. The object is stationary between hours 3 and 5. That is true. Accelerates. We haven't even talked about acceleration yet. The object moves at a faster speed between the 4th in the 6th hour. That's not really true because it was stopped here, but it was faster there. The best answer is it's stopped or stationary between here and here. At which point does the object experience the greatest change in speed? That's going to be here. Bigger slope, more speed, and so that's between 5 and 8. Do we have a 5 and 8? At what point does the object experience the greatest change in speed? That would probably be between 5 and 6. 6 and 8 is also a possible option, and so I actually made both of these worth points. This is technically the better one because we go from stopped to a faster speed, but I also counted this as a correct answer too. What is the average speed of an object between 0 and 3? Oof. So we need to know the speed. And so what we need to do is come here. It looks like it's 30. Okay, this is in between here. 40 and 20. In between 40 and 20 is 30. Okay, divided by 3. 30 divided by 3 is 10 kilometers per hour. This was a bonus question. It was how to calculate this was in a couple of our assignments, but this was a bonus. What kind of relationship can be seen by the red line? Red line, it's going down. We call that an inverse relationship. Down is inverse. Green line, it's going up. Now that's a direct relationship because 1, 2, 3, 4, 5, 10, 20, 30, 40, 50, boop, 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 increase. An object travels 60 kilometers in 2 hours. What's the speed? 60 kilometers in 2 hours. 60 divided by 2 is 30. Okay. Car's moving 100 meters in 10 seconds. What's the velocity? 120 meters divided by 10 should be 12. If you divide by a 10 or 100 or 1,000, you just remove the zeros, however many zeros it's got. This one, let's just remove a 0. Whoop, and so it's 12. If a cyclist covers 45 kilometers in 3 hours, what's the cyclist's average speed? 45 divided by 3 should be 15. Is that an option? It is. There's the answer for this one. All right, let's go do this one, which is the writing section.
Attention teachers and students.
We have an announcement.
We need members of the Select Men and Cantate choir groups to go to the choir room. Select Men and Cantate report to the choir room at this time.
Okay, claim. The object comes to a complete stop at some point during this journey, then returns to the starting point. Well, let's just look at what's happening here. Here's our start. We've traveled some distance. We're at 20, we're at 30, we're at 40, 45. We stop for a second, and we start working our way backwards, back to 40, back to 30, back to 20, back to 10, back to our original spot. And so, object comes to a complete stop at some point of its journey, then returns back to the starting point. That sounds like it. Went here, it stopped, and it came back to where it came from. So, we need to restate the claim. Let's do that first. The claim was copy, paste, done. Do we support or reject the claim? I would support that claim. I support the claim. Use appropriate numbers from the table or graph. Okay, so let's pick some numbers and describe. It starts at 0. It gets to about 45 at hour 3. Stays there till hour 5 and returns back to 0. So let's write that out. The object starts at 0 kilometers and then travels for 3 hours. Let's use the units that we were given here. Hours, so travels for 3 hours to 45 to 45. Is it meters? No, it's kilometers, to 45 kilometers. The object stays at 45 kilometers for 2 hours. The object then returns to 0 meters in, how many hours did that take? 1, 2, 3, 4, in 4 hours. All right, so did I use numbers from the graph or table? Yep. And did I use units numbers? Yep. There we go. That should be it. All right. There should be a password at the end of this video. Use that password, copy and paste it in to take the test. Good luck.